All right, everyone. It is 12:20, so we'll get going. So everyone, welcome to the Tech Talent Accelerators ExploreTech seminar today. Um, today we will be having a talk by Andrej Zdravkovic, who is the Senior VP and AMD Markham Site Lead for AMD Canada, and it will start shortly. I apologize if you're getting those notifications in your sounds. I hope you can all hear me. If you're having any issues, please do mention it in the chat function, and Jessica who's on the line can help you troubleshoot there. So to start, we'll just do a land acknowledgement. Toronto is in the dish with one spoon territory. The dish with one spoon is a treaty between the Anishinaabe, Mississaugas, and Haudenosaunees that bound them to share the territory and protect the land. Subsequent Indigenous nations and peoples, Europeans, and all newcomers have been invited into this treaty in the spirit of peace, friendship, and respect. So with that, I wanted to start just kind of give you an overview of what our agenda for the seminar will be like. I'll take a few minutes. My name is Adnan Syed. I'm the director for the Talent Accelerators program here at Ryerson University. And I'll be doing a couple of minutes just to give an overview of the Tech Talent Accelerator. And then we'll get into the seminar, and then there will be ample time available for Q&A with Andre at the end. So at this time, just for the participants, if you could please in the chat function, if you could mention, what program are you in and what year are you in your program? If you can put that in the chat function, I would really appreciate it. All right. So moving ahead, so just want to give you an overview of what the Talent Accelerator is, the Tech Talent Accelerator. So it is a program where we're looking to transition students from university to the industry, specifically to the Canadian IT tech sector. And this is a partnership with between Ryerson, CompTIA, which is the largest global association for IT tech companies, and its member companies. And we're also funded by the province of Ontario's Skills Catalyst Fund. So what our program does is we do two activities. There's these two bubbles that you see on your screen. We run a ExploreTech side and an ExperienceTech side. On the ExploreTech side, this is really for students to get exposure to the tech industry. So just like the seminar we're having now, the idea is to bring leaders from the industry to share their insights about the industry and about their part of the industry and what could be valuable for students to know as they consider the tech industry as a career. And so that we host seminars at least once a month, but at the moment we are doing it at least twice a month is what we're thinking of as a schedule. But at minimum, we'll be doing this once a month from September to May. And then once a year, we'll host a hackathon. So this will take place late January is where we're looking to launch this. It will be called Hack Tech. We'll identify an innovation challenge with our industry partners, and we'll have students participate in coming up with a solution for that industry problem that's posed. So this whole, again, the idea here is, as students, we'd like you to get exposure to what the tech industry is about here in Canada, and more specifically here in Ontario and Toronto, in the Greater Toronto area. And you can do this by regularly attending our seminars as well as participating in the Hack Tech Hackathon. And this is available to all students in all disciplines across Ryerson University. Even faculty and staff and community members of Ryerson are welcomed and appreciated for joining. So that's the ExploreTech side. And then the ExperienceTech side is where we're looking to transition final year students into roles in the tech industry. And the way we're looking to do this is what we do is we offer them kind of pre-internship training about the industry. So these are these modules that we've developed with our industry partners. And then with our partnership with CompTIA, which has an extensive certification program, there's an in-kind course and exam that's covered under our program through CompTIA. And then with our industry partners, we look to have students secure an internship as well as a job shadow within that company for that period. So just as a Reminder for final year students graduating in April of 2021, the deadline for you to apply for a May 2021 internship with us is at the end of the month. So it's on November 30th, 2020. So idea then at the bottom I show you is really the idea here is you're studying in disciplines, and we're looking to as students, you're studying in a discipline, be it engineering, science, business, arts, other. We're looking to transition you into the industries that are out there here in the Greater Toronto area as well as in Canada. Just wanted to acknowledge the advisory board. This is the advisory board. A number of them are here also in our event today. They've joined us, and just want to acknowledge that they've helped design and create this program, and really have helped shape what this program is. So it is designed by industry for industry. So it definitely has that input in there. So just as a last piece, I wanted to just mention that our next event will be on November 25th, and we'll drop a link in the chat function for you to RSVP for that. So this will focus on kind of sales in tech. So sales in tech is a critical aspect of any company, and we'll have a roster of panelists as well as a leader in sales in tech talking about this. So without further ado, then I'd like to start with the seminar. So this is again focused on innovation, graphics, and software by Andrej. Andrej is the Senior Vice President responsible for AMD's software group and AMD's marketing site leader. He has over 30 years of hardware, software, and business management experience in high technology product and software development. Prior to joining AMD in 2015, Andrej served as Senior VP with Geesken De Vriend Banknote Processing Division, responsible for software solutions business worldwide. Andrej joined Geesk and De Vriend in 2009 as VP R&D and led the company's software technology roadmap to create Banknote's software business. Andrej spent the previous 11 years at AMD and previously known as ATI and in various, as a subdivision ATI, in various software engineering leadership positions, including Senior Director of Handheld Software, Platform and Customer Engineering, Director of Software Development, and Director of Mobile Software. Andrej holds a BSc and MSc in Electrical Engineering. Andrej is a professional engineer in the province of Ontario, Canada, and senior IEEE member. He has published over 30 technical papers and has 5 granted patents. So with that, I welcome you, Andrej, to the Innovation Seminar. I will now stop sharing my screen so that you can share yours and you can take it from here. Again, welcome and thank you for doing this with us.
Thank you very much, Adnan. Let me see if a person who speaks about technology is capable of sharing the screen as well. It's a first test. So can you confirm that you can see my screen right now?
We can confirm that you can see the screen and we can hear you clearly. So,
perfect. Thank you very much. Thanks for the introduction. It's it sounds very important when you put all these things together. But the key point here is that I'm coming to give you an overview of innovation in the industry that I've been spending most of my professional life and work. And what I'll try to do, I'll just try to give you a very brief introduction on myself and on AMD. But then I'll focus on innovation in a few different areas. I'll speak about user interfaces. So what happened to user interfaces over time? And we'll start the way back and you'll see how this goes. And then along with that, what happened with the software industry? It's what happened with the operating systems, because today we are kind of completely used to Windows and Linux and Android or iOS or Mac OS, but there was an evolution that took quite a long time to get to this point, and I'm going to focus on Windows for that. And then as an enabler of the industry, AMD, or before that ATI, worked for well over 20 years now to create the best possible presentation of the work that programmers do to create these brilliant pixels on the screen. And I'll give you the idea of the graphics cards and how do they evolved during time. But it's not all about the shiny stuff. The basic tools, the evolution in tools that enable us to do all this is absolutely phenomenal. And I'll give you a little bit of a story of what AMD did in the line of tools, and then maybe a few data points on the recent very cool stuff that you're working on. So with that, I'll just start moving forward, and let's go to the kind of a brief introduction. Andan already kind of gave you an idea of my experience, but I started as an electrical engineer, kind of ended up focusing on software quite a bit, and then at one point in time kind of shifted to first being an architect for software, but then a manager for software, and now I'm managing the software for AMD. um, I went to school in Europe, in what used to be Yugoslavia. The little arrow is pointing to the place where I was born and where I went to school. But then in Canada, I am a professional engineer in province of Ontario, and I'm senior member of IEEE. So this is where I ended up doing last 25 years of my professional career. I've done a lot of research before in my career, a lot of innovation that kind of comes with patents and some publications. But as you go through your career, you have to make a decision whether your focus is going to be entirely on innovation, on technology, and you get into becoming an architect of the solutions that various companies do, or you find yourself in the situation that you are good in organizing the team to do something, understanding the concepts and systems, and that's the path that I've taken, and that path leads you to manager, director, vice president, whatever the titles may be. With that, it's important to know AMD and as a company, and what we do and what we stand for. And what I'm going to do, I'm going to give you just one slide on extremely high level of what AMD stands for. Our vision is that high performance computing, high performance graphics, high performance display, high performance machine learning, the CPUs, that's transforming our lives. And that's very visible in last this year with the impact on COVID and all of us working from home, using these tools in a very different way, something that we haven't anticipated a few years ago. From that, AMD created the mission, and our mission is to build great products that are taking us to that generational leap of computing, graphics, and visual experience. So the whole presentation that I'm going to go through is really defining that vision and defining how AMD, ATI before that, because I'm going to cover both, have contributed in a small way to the overall advancement of technology. And let's go through history a little bit. Let's talk about user interfaces. Well, a little bit before I really started working, the computers were very interesting. They had switches and push buttons, and in order to program the computer, you would use a hex code, and obviously you can see there are A, B, C, D, E, which is kind of a set of hex numbers above 9. You would set the code, and then you would hit right, and then you would go to another opcode that you would enter, and results were coming on the bulbs. The next level was monitors and keyboards, a huge advancement that initially started with printed with punch cards, and came to a complete transformation with the central server and the terminals all around the building. A huge advancement over push buttons and lights, but then when you think at what PC industry has created, coming from a very small, um, IBM created their PC Junior as a personal computer, and there were many estimates that this is really not required. Why would anybody need a computer at home? To to a full-fledged this one represents a gaming high-end PC with keyboard, mouse, and kind of fantastic displays that we are going to focus on. That evolved with phones and tablets. It evolved to touch interface. It was to different type of interfaces where you get kind of different types of interaction than compared to using a mouse or a keyboard. And of course, the gesture and voice recognition. It's how many of you today, rather than typing in your message, can speak to your phone and interact with Siri or Alexa or Cortana, and get the work done that way. So that's a significant evolution in the user interface from that perspective. But it's even more fascinating what happened with operating systems, because this UI, that's something that you have witnessed already. And of course, if you speak to your parents or maybe grandparents, you get that notion of what happened with the computing world. Operating systems, that's a little bit less kind of visible and known, but I'll take you back to 1985, the Windows 1. Windows 1 came back as an assembly of few windows sitting next to each other, and created they had one of the visual games in there, which was extremely popular. It was called Reversi. It was 16-bit graphical interface, so it's a kind of a minimal amount of color, and the flexibility of these windows was well, you can open and close them. That was about it. Um, Windows 2 came 2 years later, and for the first time, the windows could overlap, and they were not kind of a fixed size. They were you were able to minimize and maximize them. Uh, Windows at that time introduced a notion of control panel, so the something that will be able to control the operating system, or user will be able to do something a little bit more than on a usual operating system. And the first version of Word and Excel showed up to that time. Uh, the huge move started with Windows 3. The Windows 3 and the evolution of Windows 3, which was 3.1, created a high-level graphical interface, created a kind of colors and grayscales, created windows that could overlap and move around the screen easily. And then in 3.1, the fonts became TrueType, so very scalable with the Windows. They also came with the Minesweeper at that time, and that was extremely popular. So these are like very early Windows, but that was the evolution of Microsoft DOS into something having the visual representation. And they move forward. They with Windows 95, this is the first Windows that kind of resembles modern Windows. Windows 95 was extremely popular. It had multitasking, so you could do a couple of things at the same time. It created a start menu, so the notion of that you will kind of not have icon on the screen, or not have to go into the various folders, that it's going to be just enough to go start menu and then search the things that you want to do. For the first time, they had Internet Explorer. And from a graphics story, for the first time, Microsoft created an interface, like an API, that is going to provide graphics. DX2 and DX3 were not really usable at that time, but they started providing the base for the next level of work. A year later, Microsoft had many evolutions of that, their DirectX API, and in '97 they came up with Direct Draw. So Direct Draw was a revolution from that perspective. It was an API that would provide all the 2D graphics primitives in a very simple way, and that's what started creating the new graphical interfaces for the history, really. In Windows 98, this was really a final step in creating the basic DOS-based Windows. They came up with a Windows driver model. So for the first time, you had plug-and-place drivers that were working easily with that new model. Microsoft DirectX 6 was for the first time really moving out of that 2D into multi-texturing graphics. So basically, you would be able to create a triangle that would be projected on a screen, and then you would be able to overlay a texture over it. And then the evolution continued with adding dramatic changes into graphics. The graphics industry started excelling during that time. So the hardware was starting to support transformations, the clipping, different lights, and at the end they came up to the point the direct draw as a just a simple, relatively simple 2D interface is really not required anymore. The industry is moving from a graphic side to pixel and vertex shaders. The idea is that you are going to have small RISC processors in a graphics chip that are going to be able to run these pixel programs and vertex programs and do amazing things with graphics. From Windows 98, Microsoft went to Windows Millennium. That was not well accepted release. I'm calling it the release to skip here, and I'm hoping nobody's going to complain very much about that. But it really didn't play well. While Windows 98 stayed with us for a very, very long time. Um, okay.
So please, sorry for interrupting again. Please continue.
Okay, I apologize for this. Let's go back. It's kind of an interesting um, uh, to make a switch on Windows, because we are going into area where Windows has switched from the DOS-based Windows into a Windows NT technology that was at that time used only for server, and they created the Windows XP as the next step in in technology, and that's the merge of two. Windows codes that then created something very new from a graphics perspective. In 2007, and I was a part of that development, quite involved. Microsoft created Windows Vista. This was the first version of Windows that started using 3D as the interface for your basic desktop screen. This is what started creating these beautiful transparencies, transitions, and created this modern look of Windows. Well, the first one was very complicated to come up with. It took quite a while, and Vista was really not a great release itself. But then Windows 7 came up, and Windows 7 really was everything that we learned from Vista and moved it to the new world with a new DirectX 11, which is very close to the modern graphics interface, a little bit on a high level, not allowing game developers to do very specific things, but very, very capable. And then going forward, uh, Microsoft experimented a little bit because tablets became very popular. Windows 8 came up to mimic the tablet interface. It was not popular at all. Windows 8.1 was kind of a way back to the older version of Windows, and then in 2014 is what when Microsoft created Windows 10, which is the base of the Windows today. Windows 10 has many incarnations, and it's released a couple times a year from that point. And they also at that time introduced DirectX 12, which is the new API for graphics rendering at a very low level, allowing a fantastic level of control of a graphics card and enabling the application developers to create something really, really new. So we see the Windows, how did AMD and ATI cope with that during the time? So what are the innovations in the graphics cards that happened during that time? And I started working in ATI ATI was bought by AMD, and that was an interesting point of creating a history where a graphics card and CPU came together for the first time to create something that in AMD we'll call APU. So this is usually the combination of a graphics processor and the CPU in one chip, powering most of the lower-end notebooks today. So the first try on graphics was something that we call Hercules graphics. The only way to program that, and many of these later coming back, was just to really write on and off dot on a screen. And that has improved with a direct draw in 1994, and with the Mach 4. This was the first graphics cards that really had some level of 3D acceleration. And you can see they are very old looking, very basic at that time. But then ATI came its glory days, created the Rage product, and this was the real 3D graphics at its best. ATI managed to capture a whole lot of the market, and also with the Rage products, managed to get into the notebooks. So notebooks until that time had only graphics that was a 2D. The most popular company at that time was called Chips and Technologies, and ATI took that market with these RAID chips completely. And then ATI came into a change, creating new DX versions, new type of graphics cards, and this is the time when we started calling these graphics cards Radeon graphics cards. And you can see the size of these graphic cards is different. The sizes of the chips on the graphics card is smaller. You can look at the red one at the bottom. So this is where right now memory chips are surrounding the graphics chips. Graphic chip is very small, but it's on a very big substrate, so we can pull out the pins to the memory. After the merger, both companies, AMD and ATI, were trying to find a way. It's while the company has seen the vision, the products really didn't demonstrate that vision extremely well. And I'm calling this not so glory days. There were like a few years where the graphics cards kept coming out, but they were not at the top of the line. That was the there is an ups and downs in any innovation, and I think we at that time a little bit suffered with our North Star. Where do we want to go? And then we created a rebirth of the Radeon product and came up with in 2013, 2017 with a number of new Radeon products that started again to capture the performance crown. Not quite yet with the Vega generation, but then we started creating a new sets of graphics. And right now, just actually yesterday, our new graphics cards came out. They were announced about a week ago with a completely new architecture. We call that architecture RDNA, which is kind of Radeon DNA. And what we did with the new architecture, and that's where you can see the technology skip. We are 2 times faster than the previous generation. We have 50% better power per watt, so performance per watt. So it really means that for the same amount of power, we run 50% faster, and we are delivering the best possible version of the DX12 with that. And when you look at, I'm just showing you some slides that are speaking about that technology, but it's really kind of switching to the next level. And what is bringing that next level? Innovation in various ideas. It's not just one piece innovation. It's coming together. So our compute units, these shader units that are the essence of graphics right now, they are now created with very high performance. But we have also created something that we call infinity cache. The memory that is very far close to the graphics card, a graphics chip, and can much faster produce better result. And in order to have these two work together, we actually had to create the high-speed design, and this led to advanced features on that. And if you look at the efficiency of the high performance units, you actually see that they are kind of designed by very fine-grained clock gating. We have rebalanced our pipeline. So basically the chip lights up when you look at it in a thermal scanners completely because the pipeline is powering every chip in an equal way. And these data paths are completely redesigned to allow us to get into that level of efficiency. And you see, one innovation like innovation cache, Infinity Cache here is something that is in certain aspects of our design, and it's depicted here by these lines on a chip, gives us more than 2% bandwidth without really using too much power. So that's the whole idea of that part of innovation. And I'm just trying to kind of set the points for various questions about innovation more than giving you the details of a technology. You can read about this technology on that. And of course, we are currently the leader in the technology of manufacturing graphic chips. The graphic chips are manufactured with what we call 7 nanometer node, which means that the lines on a chip are 7 nanometers thick these days. So this gives us a huge performance boost over the previous 10 nanometer node. But just look it up how thin 7 nanometers is. We are kind of approaching the atom lengths in these or atom widths in these designs. Very, very complex designs that still use lithography, but get to the point of where light is bending around our masks when we create this kind of a design. And then for graphics, performance is extremely important. Performance without using too much power is absolutely essential for desktop, but also for notebooks and any other designs. So we are measuring in graphics usually this metrics of performance per watt, and we are getting to 55% better than the previous design. So that's a leap in one generation. And then when you look just in performance, it's graphics is a lot about gaming, and you see many very, very popular games, and what we have achieved just year over year in with innovation and increase. And of course, we are not stopping now. So we had before that 10 nanometers. We created the first RDNA version in 7 nanometers a year ago. This one is called RDNA 2 in 7 nanometers, and we are working on the next one. And it's probably going to be even thinner than 7 nanometers. I can't tell you exactly where we're going, but we are researching how we can do that better. So with that, I look at this graphics as kind of, it's very flashy. It's kind of the best possible games, the effects on the screen. But then you get into the basics. The basics are extremely important because without the basics, without the grunt engineering work, nothing of this happens. So I'll just show you a couple of slides on tools, because tools have moved exactly the same way. They may not be that interesting. They may not have the best possible imagery to play with, but they are making the world of software go round. And how complex is that world of software? So graphics driver has more than 100 million lines of code. Just think about the printout. If I had to print that code to review something, of course, nobody does that anymore. The software delivery of the software is a factory. You have to organize it as a factory. And I'll show you this little build-up thing just to give you the idea of the environment of the hardware, software functionality, the ecosystem that we need to work in, and this tries to depict the complexity of that system that we have to work through with 100 million and more lines of code. So in order to go through that, tools are essential. And over the years, tools have very, very much moved up. The first one is not a joke. Chester was an engineer in early 90s, and complete code base of our software was in his PC. That was our backup server. Uh, then we started using PVCS as the version manager for the code. Then there was um, a company called Continuous creating the Continuous as a software. Right now, we're using Perforce and Git interchangeably. And of course, there will be a next step because this is an ever moving target. The size of the code is bigger, the complexity is bigger, and these tools have versioning tools have to give you the ability to work through that. And not only versioning tools, the life cycle of software is extremely important. So if you end up working in software, you'll see that that evolves dramatically. The first bug tracking and kind of project management system that we used in the early 90s was Lotus Notes. Then it was Remedy, which was a standard at that time for managing the flow of problem engineering, problem reports, and engineering change requests. Jira is current open standard and um, widely used for all management of the life cycle, while Jama is a tool that is used for the requirements. So learning about these tools is really important because the next generation of the tools needs to provide the systems to cope with artificial intelligence and to start using the artificial intelligence to tell us more about quality of the software that we develop. So to close with that, I just want to give you a preview of some new technologies. And some of them are kind of real. Some of them are yet to be real, but you're working on them. Because for the graphics or for anything that is engineering, really sky's the limit. So let me show you something. So I'm not sure how well does this show on your screen, but we have a wonderful picture of a Ferrari. We have a picture of the office with kind of woods and snow in the background, and we have a picture of one cosmetic commercial. These images look awesome. They are not real. They are all created. They are rendered, and they are rendered using some tool that we call AMD Pro Renderer. They are rendered using the technology called ray tracing, and that ray tracing technology allows you to follow the path of the ray of light to see how that ray of light bounces off the surfaces and then how it eventually comes to your eye. So if you look at these wonderful shiny lines of that Ferrari and you see different levels of light, that's how the artist position the light sources to get all these reflections in the rendered picture. Or if you look at the cosmetics on the right hand side, you can see the reflections of various packages in each other and reflection on that glass surface at the bottom. So that's all created using that ray tracing technology. Well, the only drawback of that is to create an image like this. Of course, you need a whole lot of programming, but then you need a whole lot of computer time to do it. So all these images are created on server farms, and it took more than 24 hours for each of these images to be created. So when you think about the movies today, this is the technology that is used when animated movies are created today. But each frame of that movie is created on a server farm and takes 24 hours. So where is technology going with that? Well, we are slowly with new graphics technology bringing that into real life. So you're seeing the first ray tracing technologies coming into basic graphics cards, coming into games, and giving us something completely new. But that's not enough because you cannot easily transform 24 hours of rendering into one frame rendered every 1/60th of the second or faster than that. But if you use new ideas and new technology, you can do something like this. This is something that we have published as innovation on Game Developer Conference last year on the your left-hand side, you have a very grainy picture of a robot, and we have published, we have demonstrated this. I don't have a video running here, but we have demonstrated this video. It was the image that was put into the Unity gaming engine, and it is using exclusively the ray tracing technology, the technology that I showed you on the previous slide. But in order to be able to render at 30 frames per second, this image is extremely grainy because you don't have enough time to cast enough light rays to get the reflection from all the details of that image. But you can do something different. You can apply artificial intelligence, and you can apply the denoising filters using that machine learning technology and inference, and apply it on all the images that are this grainy, and this is what you get with that level of technology. So in graphic chips today, we are combining both, and the combination of these two technologies is bringing this fantastic image, which could have been, if I had this here, a moving image of this this Puma type robot that that is used only, designed only using ray tracing, but enhanced with machine learning. So with that, I'm just going to close, and thank you for listening. I hope my video is still running, and I will be very glad to answer any questions or hear your feedback and comments.
Awesome. Thank you. Thank you so much for that, Andre. So I'll just request you, Andre, to maybe stop your share. I'll just put on a slide just for the question and answer period, so people have instructions on how to do that. So again, thank you so much, Andre. That was insightful. Really appreciate you sharing that with us. So really, I wanted to, then the way we can open the floor here is either you can ask questions in the chat function, or if you'd like to speak, I believe we've turned off your ability to unmute yourself, but if you have an emoticon for yes, I think if you see in your participants list, you'll see there's an emoticon for yes that you can click. You can see it in my participant list. You could see like a green check mark. So if you click that, I will name you and then I'll unmute you so that you can pose your question to Andre directly. So you have a couple of options there for raising questions. All right. So I think Hussein Haji, give me a second. I'm going to find you and unmute you. So go ahead, Hussein.
Yeah, can you hear me?
Yes.
Okay, my question is regarding the new release of graphic cards that you just launched yesterday. And by the feedback that I personally had, my experience and what I have read over the internet, the availability was very, to put it lightly, disappointing. Do you have any comment to make on that?
Well, sure. It's yeah. It's the X6000 came out yesterday on the market. We are pushing the volume every day. The availability was better than what you have seen from our competition, but the key question is how much we will be able to feed into the stores over next period. And we have daily shipments. There is a reasonable I don't think everybody who is interested in buying a card will get one easily in next month, but I think the availability is definitely dramatically improving, and our partners are shipping the boards every day to the stores.
And also, I had another question. Can you discuss the Fidelity FX software suite a bit more in detail? Because throughout the launch and even after the launch, it's been very quiet, especially the competitor that you're going to have for the DLSS 2.0 technology from NVIDIA.
Yes, okay, that's a good point. So there are a couple of things. So our Fidelity FX suite is slightly different from what what our competition does. We create a completely open suite. We publish it on GPU Open, and we work with developers everywhere in the world to use and implement in their engine and in their kind of designs. NVIDIA does have DLSS, and they have kind of published a whole lot related to DLSS. We are working on a different technology, which will come out soon. That's the best I can say at this point.
Awesome. Thank you for that. So there's one question from Salman Hashim. So I'm just going to unmute you now. Go ahead.
Hello?
Go ahead.
Yep. So I have a question. So in regards to, I guess this is kind of a general question regarding the industry, because right now it seems like we're on like what, 7 nanometers, right? So I was wondering, at a certain point, does it become like not feasible? Like I was reading somewhere that maybe at like 4 nanometers, it starts becoming like not possible due to like quantum tunneling, stuff like that. So I'm wondering like what would be the next step to overcome that? Like what would come after 7 nanometer? What would come after 4 nanometer? What would you guys do?
Well, Salman, I think it's thank you. You obviously followed industry. That's first of all, over time, we have many times said, "Oh, it's not going to be possible to go any smaller," and we have been proven wrong. What has uh, what has changed is Moore's law of kind of a performance and technologies doubling every 2 years. That's not really happening anymore. The the switch from one node to another takes more time today because it's really challenging from a technology perspective. So of course, everybody's seeing that one point in time, we are getting to, as I mentioned, to the lines that are just only a few atoms wide, and there is, as you say, the quantum tunneling and many other effects. Just in general, creating these devices using lithography, because you have a mask and light on the top, and light kind of goes around the mask at these thicknesses. So many technologies are in play. The technologies that I think everybody is experimenting and we have released in our servers is technologies of a multiple dies on one chip surrounding the memory. So really trying to get into a situation where you don't have to grow the size of the chip dramatically, because the problem is we want to get faster technology, so we reduce the size of the chip. But if we are reducing the size of the chip by technology and increasing the complexity, then it's a wash. So the current trends in the industry are more divide and conquer trends.
Thank you, Andrej. So there's another question now from Joshua. I'm just about to unmute you, Joshua.
Hello.
Yes, we can hear you.
Okay, thank you. I just remember in about 2 years ago, they had something come up about, since we use silicon for our graphics card, and I remember that there's new study on something called gallium oxide that was gonna help us reach a new level of the nanometers, the bandwidth. So I'm wondering, I haven't seen anything about this new element or composition to be used. It just fell off. I just never saw anything about it again. So is that something that's still under consideration?
I'm not in the silicon design process, so I really I know exactly as you do. As I heard a few years ago that the technology coming up, but I don't know if our partners or even our silicon designers are exploring that at this point in time. I apologize, Joshua.
Okay, so it's a matter of whether or not we're going to use this new thing because it's estimated that silicon would have reached a limit sooner or later. So it's something that has I think the element structure in itself has a greater width between each electric level, so energy level. So I was wondering why, or when rather. So thank you.
Thanks. It's a similar question to Salman's question. It's
Yeah.
the different technologies will need to be deployed, and of course, research is going on. I don't think anybody, because it's so proprietary, will be able to discuss exactly what they're working on. And I specifically don't know if that's technology that's going to be used.
Okay. Well, thank you so much.
Thank you. All right. So one question I have, Andre, in the chat function. So there's a question about what are some skills you would recommend students should focus on in computer science engineering during their studies to complement their degrees in graphics specifically.
Okay, that's so. I think there are two important things that I would kind of advise really. Overall, understanding the complete system and understanding the top to bottom how the system works, I think it's very important. So I would urge you not to focus on a single area um, uh, only. It's very good if you become an expert in a single area, but if you don't understand how uh, that piece of technology links to everything else, that becomes a problem for overall growth. Unless you have a complete vision today that 20 years from now you want to be an absolutely ultimate expert in that really particular thing, which usually is complicated. So I'm looking at computer technology and software specifically, understanding different layers of software. So understanding the applications, understanding the in graphics would be very interesting. Understanding game industry, understanding couple of game engines, but it's also then important to understand how that game engine links into the lower levels of DX, how that DX links to the kernel mode level driver, and how does it links in the operating system. So let me tell you about our software engineers in AMD in Toronto, in Markham office. Uh, uh, Significant portion of them are really working on a kernel mode drivers, and they're working on that low level that makes the engine for everything else. So understanding that level is very important. Specifically in graphics itself, so focusing on understanding the programming of the shader is a very sought for kind of experience right now. Understanding the compiler and compiler technologies is very important. So it's very interesting. In graphics, you have this high end, very visible game engine programming the games and doing a whole lot of kind of visual interesting stuff. But significant amount of work is done on the lower levels, taking that game engine code and converting it into a machine readable ISA code.
Okay, awesome. Thank you for that, Andre. And another question I have is on the chat function is about the application that AMD technologies that you just mentioned. What are the possible applications in EVs and autonomous vehicles?
Okay, so the technology, the portion of the technology that I mentioned is quite important. The machine learning piece of it, it is applied in autonomous vehicles slightly differently. It's applied for the in the computer vision and the recognition of the images. So. In AMD, in my software team, there are two verticals. One is related to creating graphics, and one is related to creating machine learning subsystems. So our it's usually on Linux, which I didn't really touch much in this presentation, and the stack for that we call ROCm, Radeon Open Compute Stack, fully open to allow you that machine learning and inference. Part of that is the computer vision that then gets sublimed on the smaller products to be able to recognize the imagery in the car, like a person, another car, bicyclist, or a tree, or a traffic light. So that is very, very applicable and very much linked to that. It's working exactly the same way as that transformation of the grain image to the nice image. You have to train the neural network for a very, very long time to understand the differences between certain objects. So for this particular application that I've shown you, we have trained neural network to understand what are good industrial type images, and then we are providing a grain image to that network, and it's converting it to a good industrial type image.
Thank you for that. So we have another question from Hussein. So Hussein, I'm just about to unmute you. So let me see if that's working.
Hello. Hello again. Just a follow-up to my question about the fidelity effects. Is it possible for you to provide a timeline? Because at this point, we haven't really provided a timeline for fidelity effects. And also, can you talk about the response NVIDIA's CUDA core technology, which basically makes it very easy for developers to write programs on GPU? For instance, I personally work with Julia quite a lot, and coding on GPU is much harder when I have to do it on an AMD GPU compared to an NVIDIA.
Yes, I was saying I think you're hitting the nail on the head there. It's so two things. I cannot provide you the timeline of something that is not released. So I can say we are working on it. I apologize for that, but that's how it is. Related to CUDA. I have to acknowledge that NVIDIA has a decent kind of leap in. They started much earlier. They created a very good ecosystem, and we have created a language that is similar to CUDA. It's called HIP, and I'm sure you know that. Obviously, you are into this, and we are providing tools to take a CUDA program and change it to HIP. We call this tool Hipify. So we basically take a CUDA code, run it through that Hipify tool, and you get basically C++ code with HIP primitives instead of or APIs instead of CUDA APIs, and then you can run it on AMD and you can run it on NVIDIA as well. I think going forward, our focus will be on enabling kind of programmer, very talented and lower level programmers like you, but also enabling more work in TensorFlow, PyTorch, Python, and kind of higher level languages. It seems that this is where most of the researchers are going these days. Basically abandoning CUDA and abandoning HIP and going one level higher.
Awesome. Thank you, Andrej. And then another question from Thomas. He's saying, how is the AMD competing with others like, again, NVIDIA, Intel, when it comes to developing GPUs specifically for VR experiences, especially since VR is currently quite costly for most?
I see. Okay, it's a good question. Interesting. So about 3 or 4 years ago, VR was kind of everything. Everybody came up with VR designs. There are many companies that created VR headsets, and then we had a very basic versions of VR with Google Cardboard and kind of your phone standing in front of you. VR has slowed down a little bit. It's a very interesting technology. It creates unlimited possibilities professionally and also for gaming. I mean, in the professional world, there are VR versions of various architecture tools that can provide a complete walkthrough to the newly or planned building. Repair people, absolutely amazing opportunities again. But the problem with VR is the content. While in regular gaming, you have many different games coming out daily, and the industry, like any industry, revolves around money, and the new game is sold, I don't know how many millions, while the VR games or VR content doesn't have that kind of a following, and that becomes a chicken and an egg problem. Before there is enough content, the industry is not going to completely flourish, and until industry flourish, it's going to be very hard for the providers to provide the best possible technology. So we are into this creation of the new technology, and it'll take some time, but the ability of our GPUs, ability of NVIDIA's GPUs, and ability of consoles are there. So it's all possible, but the content is still not there. I would like to hear from you if you think that there is enough content, or what's happening with the content, because I'm more on creating the enablement, not creating the content.
Okay. Thank you for that. So I think we're almost at the end. There's one more chance if anybody wants to raise a question with Andrej. We've just under 3 minutes left. So maybe while we wait, Andrej, like I'll ask you a question for myself. Just in terms of like from the presentation you gave and kind of the path you've described in terms of technology innovation. Kind of wanted to request you to speak a little bit on the personal level. What drives you and what drives this interest in kind of innovating in the graphics space? Like, well, what's exciting for you here with the work that you do at AMD?
Yeah, thanks. That's for me. It's really, I would say, once an engineer, always an engineer. I mean, when even as a young kid, I was fascinated by ability to create something new. And AMD is a company that allows me, but also allows everybody who works there to grab the proverbial bull by the horns, to dive into the technology and make a change. And I think that's the most important part of my motivation. My motivation is to make a difference, to contribute in a technology, or organizing the teams around technology and making all this happen. And again, why AMD? Because it's a company that allows me to do that, and I think allows almost everybody in the engineering workforce to follow their passion and to really take as much responsibility as they're ready to.
Awesome. Thank you for sharing that. All right. So with that, I don't see any other questions coming in. So I just want to take a moment, Andrej. Really, thank you for the time you've given here today to us, and for the presentation. Really appreciate it. And what we'll do is we will circulate this video of yours, the seminar, to the students and others, so it will be disseminated widely beyond our current live session as well. So again, thank you so much. I really appreciate your time. I appreciate AMD's support of the TechTalent Accelerator, with Mark Bonelli being on our advisory board. So thank you so much again. Take care.
Thank you very much for having me. It was a pleasure.
Thank you, Andrej. So just if you're still in the Zoom session, just making everyone aware that we are doing our next session on November 25th from 12 to 1. So this, I mean, especially even for technical students in engineering and others, I would suggest this is important, that, at the end, as Andrej just said, it's the companies and businesses run by where the money is. And so you'll get to understand, how sales in the technology industry works through this panel discussion. So even if you are on the technical side, in wanting to work in the industry, this would be a valuable insight for you as you consider your career options and directions. All right, thank you so much. And again, if our link on our chat function is not there right now, please visit our website. It would be there. Please also follow our LinkedIn page. If you'd like to stay in touch. We post everything as an update first on LinkedIn and then anywhere else. Again, thank you so much. And with this, we'll end the meeting.